Okay, so a little bit of information on this one. This is one of the first labs that I end up doing. It's something kind of related to vectors, dealing with trigonometry and ways that we could use that to make measurements about the physical world. In short, I have the students use their cell phones to take a picture of a distant object, and we have a couple of meter sticks and a few things set up so that we can get measurements, and they can play around with either similar triangles, or what they're actually doing is measuring the apparent angular size of a distant object. Okay, so materials. First and foremost, at least if you're going to do things in very much the way that I did it, camera tripod. I use that to attach the very tall meter stick, the one that's 2 meters tall. I attached it to that. I have a couple pictures of it in the field, so you've probably seen that once or twice. I connected it with the other piece of equipment that I'd recommend, a large C-clamp. So those three things together basically gave me the tall thing that I could measure the apparent size of the object with. I also recommend getting just a regular 1 meter stick and use that for the students to easily get their cell phone or smartphone 1 meter away from the 2 meter tall stick. The other thing that you will need clearly are smartphones. Pretty much all the students in my classes pretty much had smartphones. Though if you have any that don't have one, or the battery's dead or something like that, again, have them work in small groups or pairs, and then that way they can both work together, and when they sit next to each other, they can look in on the same smartphone and get the measurements that they need. And finally, the other thing in the picture here is the trundle wheel, which is something that you would need if you're not measuring something very far away like I did, but instead if you're measuring something on campus like a flagpole or stadium lights, that sort of thing. And so that's one way that you could go through and get a decent measurement for how far away that object actually is. Okay, so this is one of the labs that I came up with, well, lab type activity, that I came up with relatively recently. We tried it earlier this week and it seemed to go over pretty well. I'm wondering if I probably should have spent a little bit more time, but I think the students got what they needed to out of it, and that it's something that they'll be able to look back to and compare some of the other stuff that we'll be working on with. So the topic that was the focus of this one was trying to measure the height of a distant object using trigonometry. And so we ended up using a water tower that's a little over a mile down the road, but it's a very large water tower, and there's a specific part of campus that we can actually see it through an opening in the trees. Now, part of the bottom of it is blocked by cars, and some of the students rightly brought up that would cause a problem, which is good. Especially early on, it makes for a good one that I kept asking the students to think of ways, as we were taking the measurements, ways that would cause problems. But a brief rundown of what we did was this. So we stand over here, and we take pictures. I had them use their cell phones. I also set up a meter stick, a very tall one, a 2 meter tall stick. I'll show it with the materials, but I used one of these. It's, I think it's about 2 meters tall. Yeah, it comes up to about 2 meters tall. I've got a couple of these in my classroom. If you don't have one of those, some other measuring device could work. You could always have students work in small groups where they hold a tape measure out, though I recommend trying to use metric if you can, but it should work for whatever units you'd like. I would have them hold their cell phones, so they could actually just take a picture with their cell phones. Makes it easy, because when they go outside, that way they don't have to take paper or pens and try and write stuff down. We caught all of the data, hopefully, with their cell phone picture. But I had them use another meter stick, holding the meter stick up, and again, a friend could help them with this, where they are 1 meter out, and then they would take a picture with their cell phone so that they could record it. And in the distance, way, way far away, not drawn to scale, we have the water tower. And I did a drawing almost exactly like this with the students. But in short, we would have kind of a level line going out like this because it's far enough in the distance that it's actually a little bit pretty much close to the horizon, so it'll actually be almost level. But we'll deal with that in just a moment. And then you also have over the top a line that goes like this. In short, I had them use the picture so that they could find, let's use a different color here, maybe something, let's go orange. They use their picture to read off how tall that water tower in their picture looks on the meter stick. Try and have them focus on the meter stick if you can. Then, having this side and this side, I have them find the angle that goes in here, because we have a triangle that looks like this. We know that the bottom part is 1 meter, if you use the technique that I did. And then they used their camera image that they could zoom in when we walked back into class. They could zoom in on and read it pretty well. We got pretty good results, especially ignoring, we had, it turns out, stuff in the way, maybe some bushes and some trees or something that we couldn't actually see the bottom. On the upside, in pretty much every single class, when we first started looking over it, one of the students brought up that there were cars in the way, parked cars, that blocked our ability to see the base of the water tower. On the upside, I was ready for that, but that's also one where you can have them constantly asking them, what are sources of error? Where could, with the technique we're using, what problems do we have? Because the end goal is this. Now that we've got this angle based on their measurements, their cell phone image, it's this angle here, then it's the same angle as we have for the large triangle that looks like this, with the height of the water tower overlapping, like that. They found this angle, and then I used Google Maps and a little bit of a technique that I can show you to find this distance, which we found about 6,070 feet. I left it in feet so that they could actually compare it to something that they were familiar with when we got the height of the water tower. And then when you run the numbers through on that, we got varying amounts. The students would find something, usually based on what they could see, in about the 150-foot range. Turns out the actual value is 218 feet is the value that I found. But let's see why. So first off, this is actually a cell phone picture from my cell phone when I went outside and I did this a couple of days ago in preparation for the actual lab, so before the students. In fact, when the students came back in, they saw this exact PowerPoint that I put together. I brought in my picture, and the beauty about their phones, and my phone is, it takes really high resolution images. They should be able to zoom in at least a little bit on their phones, but they run into a bit of a limitation. I've actually set this up when you load it into PowerPoint, and this is something that you could do if you want more in-depth measurement. For me, I didn't want to spend all the time on that, but this second slide, these are both the same image. I copied it, and then I just made this one much larger, which we can see much more clearly because it's at much higher resolution. So this red outline here is actually the section that we see here. I do that quite a bit whenever I do inlays, so people know exactly where it's coming from. Here's the meter stick, here are the cars, and here's the water tower in the distance. The meter stick, which I focused on, the cars, and then the water tower. And as we mentioned, this car is actually blocking the bottom of the water tower. And if it weren't, I think other buildings would as well. On the upside, students brought that up. I prepared for that, so I went over and I drove to a spot where I could get a picture of the water tower where I could actually see the base of it. And this is that picture that I have here, outlined in orange. I shrink it down a little bit, and then I put a bubble over the water tower in my picture, the one with the meter stick. And then I copy that bubble, once I've got it the right size, onto this one, and I adjust the size of this until they're the same. And I asked the students why I would do that, and many of them brought up, well, at least a couple per hour, because I kind of open it up as a broad question, then let whoever wants to answer it. And they say, because it puts it in scale, so now here's the top of the tower, and I know that the bottom of the water tower would be here in the cars. Now, I told the students that, because I don't have computers in my classroom, after showing them this, they could easily do this, but it's not something that we would be spending class time on because it would take a disproportionate amount of time to do that. The important thing is they understand the measurement that they're getting here, and they understand that theirs is probably going to be a little bit smaller if they use the number that's specifically here. I let them choose between either using this number that they can see outright, that they know is good, and that they know will be less than their actual value, or based on what's projected up here, they could kind of estimate. And so either of those are fine, as long as they've got a decent understanding of what they're doing here. They're trying to find, once again, when they read this distance on the meter stick off of here, they're finding this orange side. Combined with the red, the meter stick, you can find this angle, and that angle is the same angle that goes all the way out to the water tower. All you need is this final step here. And that is on this other slide of the PowerPoint. I brought up Google Earth, or Google Maps, I should say, and I went from our school, Edmond North, all the way over to the water tower, some distance down the road. So this is actually a view of what we're dealing with. I took the scale bar at the bottom, and you'll notice this red line that I physically drew, and here's another red line that I physically drew. I used this on the scale bar to get a ratio. In PowerPoint, it tells me that the length of this line is 1.44 inches, I think. And so that's 1.44 inches, gives me 1,000 feet. I find the length of this line, and then I know the actual value to give them, which is the 6,072 is what I found, but 6,070, maybe 6,100 feet would be a better value to go with. I recommend running through the numbers yourself, making certain that you've got a decent value beforehand. Now, you may not be lucky enough to have a water tower within sight range or something like that. That might be interesting. You could always use a flagpole or the lights at the football field or anything that's relatively tall. Now, if you're going to use exactly the technique that I'm using here, where you can just use the apparent size on this, which makes it a little bit easier, you're going to want something pretty far in the distance so that you don't have to worry about your actual height. The other thing about it, some other things that the students brought up is possibly how much you zoom in on your cell phones, though I don't think that would actually cause any problems, but also whether or not you're holding your cell phone level. Of course, if you take a picture like this, that's pretty good. If you take a picture like this, that may not get you the reliable values. You want it to mimic this triangle, and for that you want to be kind of nice and vertical here, not looking down. So, but go through, you can also ask them places where error could be brought in, and all sorts of other stuff. So this is mostly me still playing with the water tower. I have another PowerPoint in which I did the same thing with a skyscraper that's about 10 miles away, and I gave them some of the numbers on that and let them play with it a little bit, but we weren't in a position where we could actually see that from the school, and I didn't want to get field trip forms, that sort of thing, and try and take people off school grounds. So you'll probably be limited by whatever you can access on school grounds. Though it's been my experience, students like it when you go outside, they like the fresh air, and most of my students seem to really enjoy the prospect of they were using something mathematically that they could find something physical that they cared about. So this is one of the first labs that I'm doing at this point. The final thing that I will mention, and I did not use it because I used Google Maps, but you can also use our dear friend the Trundle wheel, which I've mentioned in some of the other stuff that I've got, but it allows you to go through and make long distance measurements pretty easily. It's got a little clicking part in here that every time you go one complete circle, it clicks, and you just keep a mental tally of 1 click, 2, 3, 4 meters and 87 centimeters, because it's marked around the edge here. And so you could use this if you were measuring, say, the flagpole there on campus. You could use this to get that distance, this distance that you need here. Now, if you're measuring something that's very close comparatively, then you're probably going to have to make some adjustments on this, where this thing isn't so far in the distance that the bottom part shows up here. You may have to take into account your actual height here and add that on to the value down here, depending on how close your object is. Okay? So, my recommendations are, if it's something very close, you'll have to take some extra steps in this, which I think can confuse some of the students, I could be wrong, or measure something very far away if you can, and the very far away, hopefully it's very tall, and the students will probably be interested in it. Okay, so hopefully that helps.